Let's now set up our Eclipse environment so you can use Scala Worksheets as a REPL. The first thing we want to do is to make sure we have the Scalding REPL dependencies set up correctly in our Maven POM. We'll save this and then go ahead and create a new package calling it REPL, just to keep things organized. We'll also want to create a Scala package object, and I'll pause here for a second to clarify what this is. In an OO language like Java or Scala, you construct your program through a series of classes and the relationship between them. For every class, you can create an instance or an object instantiation of that class, which acts and lives as its own entity, with the class members, properties, and methods acting as the contract of how that object behaves. Simple object-oriented programming here, nothing really special. Now, sometimes you want to follow a pattern that essentially allows you, the developer and user of a class, to create only a single instance object of that class. This is simply a singleton pattern, and believe it or not, as simple as it seems, it's not very trivial to implement and get right in a multi-threaded environment. Scala, however, makes it really easy for you to indicate that the implementation of your class is intended as such, i.e. a singleton, and that only one instance should ever exist as an object for this class. To do that, you would simply replace the class definition with object. So if we had a class called helper, to create a singleton out of that instead, you would write object helper, and everything else remains the same. You would use object classes in Scala instead of what static classes would have provided you in Java or other programming languages like .NET. Package objects in Scala are a special type of singleton object. Package objects basically allow you to make functions, fields, and other code available at the package level, allowing for much easier code reuse and availability, which is what we want to do here. We want to create a package object with the code necessary to set up our environment such that we get REPL-like functionality without having to repeat this setup over and over again. So we'll start by adding all the imports we need. We'll then simply follow the requirements necessary if we plan to run scalding outside of the context of a scalding job, meaning that we won't be extending from job as we would usually do. And as a result, we don't get all of the free stuff we would normally get, so we'll have to include those bits on our own. And that basically includes having implicit mode and flow def variables and a set of configurations. Now, what we want to provide is a higher order function that we'll call flow. This function will set up the cascading flow for us, and will take another function as input, which is what makes it a higher order function. The input it takes will serve as the scalding pipeline that we'll build outside of this package object definition, as part of our Scala worksheets. We'll take a look at that part shortly. The flow function takes an operation that returns unit. This variable could be in the form of a function, and it will essentially implicitly get called every time a call to flow is made. This unit returning variable or function is where we'll provide our logic in a Scala worksheet, so let's go ahead and do that. Remember, the purpose of this is to use Scala worksheets to ease development. So we'll create a new worksheet and call it Hello World. Scala creates the worksheet with a simple print line illustrating how this works. The idea is that you write your code here, and each time you save the worksheet, it will execute your code top to bottom, and show any results you output to the right of the code. Let's go ahead and call our flow function, and remember, this is possible because it's defined as part of a package object, and we're in the same package, com.pluralsight.repl. The flow function takes an operation variable that returns unit. We can substitute this variable with an anonymous function that returns unit, which will get executed every time flow gets called, which is exactly what we're doing here, making a call to the flow function every time we hit Ctrl S to save the worksheet. I'll just paste the code we use in our simple pipeline to illustrate the concept, and include the REPL imports for the implicit conversions. These are the Scala implicit conversions that we'll need to have in scope so that scalding can actually implicitly convert a cascading pipe to a rich pipe, and so on and so forth. We'll use the Scala worksheet in a lot of the demos that follow, so you'll get used to seeing this. I'll hit Ctrl S to save, and as you can see, our code executes, and we have our worksheet output file as a result of executing the scalding workflow. While our flow didn't output anything, the worksheet still shows some output that is getting in our way, so let's get rid of that. We'll go to Window, Preferences, and under Scala Worksheet, let's increase the character limit per statement. This allows us to have a longer output without trimming off the results. And we'll also just set the parameter for the default log level to warn instead of info, because we don't want to see all of that convoluting our output. Hit OK, and then let's try this again. you'll see the file's timestamp updated, indicating the scalding flow did in fact execute and we have a clean worksheet. I know this was a bit of work, but you'll only have to set this up once, and then we can easily start creating scalding workflows and start testing them.